first thing you have to think about when you're considering implementing a machine learning or AI model to solve a problem is, first of all, how do you solve it today? And what does that look like? Is it a person that's doing that? Is there a piece of software that isn't ML that's doing that? You have to have a very good understanding of what it looks like today. If there's no solution whatsoever today, then it's likely not an important enough problem. So it's helpful to start there, because that also gives you the foundation to start building on top of it. So before implementing ML, you want to understand how it's solved today and how good the solution is. Because it's very likely in some cases that the solution is good enough, or might be like even significantly better. Especially if it's solved by humans, it's likely better than what a model will give you. Maybe it's less efficient, it's more expensive, but in most cases humans will do these tasks way better. So you have to understand that. And if you're coming from the business side and you know how it's solved today because you run that team, for example, and you see a lot of inefficiency that you think could be improved with ML, that's a great opportunity to bringing a data scientist into the conversation and really lay out the problem in front of them and how it's solved today. That is 10 times more productive than just giving a budget to a data science team and telling them, find problems you can solve. Because when a data scientist would see the issues, will see the problems, you'll see how it's solved today, I'll make their life way easier to map that to potential machine learning solutions or algorithms, or really how to position this as a data science problem. And then on top of that, in many cases, especially if it's solved by humans, maybe you could use those humans who are currently doing that as a method to generate your training data. Because without data, it's impossible to build a model. So if you have humans, for example, let's say we're an insurance company and we're trying to build a computer vision model to identify claims from images of cars. And so if you have humans doing that today, you have the images, you have a person that marked the image, whether this is something that's happened from an accident or not, for example, and suddenly you have a lot of the training data ready. So a data scientist can come in and look at that data and tell you, this is something we could tackle with machine learning, especially specifically in this case, computer vision, or not. And if not, what else is necessary? Perhaps it's not sufficient to just know that the image has something in it. You actually need, for example, the bounding box, where exactly it happens. So you would go through another process of labeling, but you got 90% through. On the flip side, if you work in that insurance company and you give the data scientists a budget and say, hey, go find problems, there's no guarantee that they'll find problems that are as important to the business like that one, for example.